Good afternoon, everyone, and thank you for being here. I'm Jesus Octavio Sigala Valdez, and today I'm glad to talk about my project in the Material Research Congress 2022 that is called Study and Evaluation of Thin Film Synthesized by Chemical Deposition for the Design of a Window Buffer Layer. This work is developed in the Universidad Autónoma de Zacatecas in Mexico. In Mexico. As introduction, we use the CELAR methodology, the successive ionic layer absorption and reaction method, to create or to synthesize multi-layer thin films to form a semi-transparent window buffer layer. This layer is desired to achieve a vanguard value in the order of 3.8 to 2.1 electron volts, a thickness in the range of 150 to 80 to 150 nanometers, and low serial resistance for high optical transmission, or about the 75%. In the literature, the cadmium sulfide is widely used as a window layer for the suitable bandgap the compound have. On the other hand, zinc sulfide is well used as a buffer layer due to a good carrier lifetime and engaged crystallographic properties. So in this project, we work to create or to synthesize a window buffer layer with a combination of both materials. One of the advantage of the CELAR methodology is that we can is not a complicated process. So in the laboratory, en el grupo de investigación en materiales novedosos y energías renovables, we develop equipment capable of control the CELAR process. One of the benefits of this CELAR process is that you can create homemade devices to study some of a semiconductor compound. So in the experimental methodology, CELAR needs needs to have four microprocesses. One is the Imrc in the cationic precursors. The second one is the rings. The third one is an ionic precursor immersive, and the fourth one is a second rinse. The rinse are have the cleaning process, and also help us to achieve homogeneous thin films. We all the four steps mentioned become one full cycle. So CELAR process control the cycles you have and the molarity of the anionic and cationic precursors to achieve good quality thin films. In the laboratory, we work in tin sulfide as a TCO, cadmium sulfide and zinc sulfide, to understand the characteristic of the compounds together. Sorry. The molarity of the cationic precursor and anionic precursor is shown in the table. With 80 cycles for the tin oxide, 45 cycles for the cadmium sulfide, and 50 cycles for the zinc sulfide, to achieve a theoretical thickness of 80% approximately, of 80%, 150, and 150 for the respectively for all the thin films. It's a theoretical thickness because we are in the search of measure the thickness of the thin films we develop. Anyway, as a results and discussions, we present to you the same image, the XRD, the Raman spectroscopy, and the UVBS spectroscopy, to understand the morphology and optical properties and crystallography properties of the multi-layer thin films. In the same image, we can observe first of all, it was configured by the secondary electrons, and we can observe agglomerate composite agglomerate for the cadmium sulfate, and a compactness and crack formation for the zinc sulfide. For the first one, the agglomerate of compounds, agglomerate for the cadmium sulfide is already studied in some of the research they make are according to these results. For the other hand, in the zinc sulfate, we have a problem. We are developed some new techniques or some new composite helping or trying to avoid the crack formation. So we can explain these two synthesizing forms to the wettability and molarity of the final product. For the XRD, we use a grazing beam configuration with the omega angle of 0.5 degrees, and we can observe here in the black line the multi-layer films, and that shows a polycrystalline behavior for the synthesized multi-layer thin films. For the zinc sulfide and cadmium sulfate, we have a cubic structure or zinc blende crystal structure, and a preferred orientation to the 002 and 11 diffraction planes respectively. This is a good way to observe that we have the combination of three compounds, and XRD helps us to understand what is happening here. Also, we have some of the signals, diffraction signals for the tetragonal tin oxide, that is the substrate of these two other compounds. For the Raman spectrography, we can verify the synthesization of the cadmium sulfide and the zinc sulfide, observing vibration signals at 300 and 350 Raman shift, corresponding to the transversal optical phonon mode for both compounds respectively. So is verified from the XRD, or the XRD can verify with the Raman. Sorry. According to the measurement of optical absorbance at a wavelength ranging between 510 and 520, the films allow more light to pass. This could be observed for the color of the thin films, that is yellow. Also, we can observe the characteristic of absorption X for the compounds deposited in the figure 7. So as a conclusion, we obtain multi-layer films for the microcontroller CILAR, show a uniform substrate coverage and low number of imperfections. The big imperfection we have is the crack formation. CILAR is a suitable method for depositing good quality multi-layer films, and also we are waiting to first of all resolve the problem of the crack formation, and later we're gonna measure the electrical properties of these multi-layer films. With no other subject to talk about, thank you for being here, and if you want to do a questions or question something about my project, here is my email. So thank you so much and have a good day.